Okay, hopefully that video helped a little bit more than my handy dandy scribbling over here. Anywho, okay, when it comes to vocabulary, I'm going to kind of break it down for you just to make it a little bit easier for you because we'll be using it in your vocabulary assignments, okay? Statistical evidence. I think you can kind of infer what statistical evidence is, but it's the data that is collected either by polling or research, anything that could be used to make a statistical generalization. Statistical evidence helps us create a statistical generalization, a generalization on what we assume something to be based on the evidence, okay? A statistical generalization is the inferences drawn from said evidence. I'm drawing this generalization, I'm coming to this generalization based on the evidence that I've been given. When we talk about science, and this is something that is very important to understand, we do not have all the answers to the universe. As human beings, we barely use all of our brain. We barely use any of our brain, just in general. We use parts of our brain. We don't know all the things. The goal behind science is to try and find as much evidence as we can to help make a point, to show an answer, to give a solution, to figure stuff out. This is why when we do, what do you call it? Oh, brain. When we do inductive reasoning, our goal here is recognizing that not all things in this world are 100%. Not all A's are B's. We know that. We can prove that, right? But the more data we collect, the more statistical evidence we get, the more likely we can infer, we can have statistical generalizations, the more that we can draw up a generalization because of this information we have. This is why peer-reviewed is so important, because the peers reviewing can redo maybe it's a scientific experiment based on a protocol. We'll get to those terms in a second. The more you do these particular, based on a protocol, doing these experiments over and over again, you should be able to keep coming up to the same generalization because of the evidence that you get. This is why peer-reviewed is so important. So if you're reading some kind of medical science journey, but the peers are like, dude, we can't get the same results you did. Something must have gone wrong in yours, because every time we do it, we have not yet come to the same conclusion that you've come to. This is why it's important why we look at peer-reviewed journals, peer-reviewed articles. This is why when you get information, who else was able to duplicate that particular study and get the same results? Because if you can't, something went wrong. Whether the experiment itself just happened to be a fluke and got the results, or the information was falsified. Okay, so these are the things you want to be thinking of when you think of statistical evidence and statistical generalizations. Okay, again, no things in this world are perfect. Not all A's are B's, but oftentimes most A's can be B's. I know that's probably confusing, but work with me. Okay, when we talk about a characteristic of interest, that's actually the question we are trying to ask. Okay, what specific question is a researcher trying to answer given a certain population? So if we were to talk about a characteristic of interest, what's the question? What question are we trying to answer to get evidence to come up to a conclusion, right? What's that question? The characteristic of interest is the question that the researcher is seeking the answer to. Okay? All right. Now, when we think about target population, we got a question. And what we're trying to ask the question is based on a target population. Okay, and a target population is the group that the researcher wants to generalize. So a target population could be all students at Butte College. That would be a target population. Say the characteristic of interest, which would be the question that is going to be asked, is how many people at Butte College chew gum? So the characteristic of interest is the question on the target population, and that target population are all students at Butte College, because that's what the question's asking. Who's your target audience? All students at Butte College. Okay. Now, this is where it gets a little tricky because we want to pull a sample from the target population in order to answer the question. So, if we want to know how many students at Butte College chew gum, who do we ask? Who's our target audience? Like, how do we figure this out? Where do we pull the sample from? Do we pull the sample from people in Montana? Probably not. We want our target population to be Butte. So the sample we have to pull from needs to be from the target population. Okay, so if we want to figure out who chews gum at Butte College, where do we pull the sample from? Students from Butte College. Okay, a sample is members of the target population who are being studied by the researcher. Okay, target population here. And then the sample size is going to be the members within, right, that target population. So the sample, the members within that target population, we need to try and find a, can we ask all people at Butte College? Like, that's kind of a lot. That's a whole lot. Well, in order to get information, instead of asking all students from Butte College, maybe we just take a sample. Well, when we think about sample, what kind of sample do we want? Well, your best bet to avoid bias, and bias is the sample that doesn't reflect the whole group. If we don't want a bias sample, then we have to do random. Random is a condition that would allow every single member of the target population an equal chance of being a part of the sample. So in order to answer the question, who all chews gum at Butte College, the sample that we need to get needs to be random. If I had an in-person class, or actually no, if I just asked my online class and only my online class who chewed gum, do you feel that that would give everyone at the target population an equal chance to be a part of the sample? If I only asked my class, just asked you, do you feel that's a good random sample and giving everyone an equal opportunity to be a part of the sample? The answer is going to be no. That's biased. And biased does not reflect the random representation of the group. It's biased because I'm only choosing you all, but I'm not pulling from all of Butte College, because all of Butte College is the online students, people at actual campus down in Durham and Orville. We have Glenn students and we have Chico students. So in order to do a true random, I'd have to throw it out to everybody, not just my online class, my one English 11 online class. I'd have to ask everybody throughout Butte. And I'd have to make it random, like anybody could be a part of this. It could be you, yes, in my class, but it could be someone else at the Glenn Center, or maybe someone at Orville, or maybe someone at Chico. It has to be random, meaning any and all people within this sample throughout all of Butte College and all their campuses should be able to be chosen in order for it not to be biased and in order for us to get an accurate sample. Okay? So when we think about biased means that you're not including all the people within that target population. You're only choosing, one class or, one particular type of person versus all of the people within all the samples within Butte College. I hope my hands help give you a visual. I don't have a whiteboard, so we're just do what we can. Okay, so I really want you to be mindful again. If we've got a characteristic of interest, it's a question. How many students at Butte College, which is our target population? The sample is going to be random. It's going to be from all students throughout Butte College, and they're going to give us an answer, each one of them. And when we think about that, the more random and the more we usually get a better feed of, the actual truth of how many students actually chew gum at Butte College. Oftentimes they'll do polls for politics and stuff. And, they'll poll like 1,000 people. And then they'll poll another 1,000 people. At this point, if you were to keep going, usually around 1,000 people actually is the best read of a random sample of political understanding. Does that make sense? So you could keep doing another 1,000 and another 1,000, but as you keep doing those same, random samples of 1,000 people, you'll start to see similar numbers. So sometimes there actually is a sweet spot of how many people within a random sample of a target population ends up being the max. You could keep doing more, but you're just going to get the same numbers, and then you kind of exhaust your resources. So usually around 1,000 ends up being kind of like the number, depending on what you're doing, like for understanding the political spectrum. At least this is how it looked in the last election, about 1,000 people. So when you think about your target population, again, you want as random as you can, as many as you can, but sometimes you might notice the data will repeat on itself. And then you go, okay, we're just getting the same answers despite how many people we are working with here, okay? That's why oftentimes you might see a scientific study and you're like, oh, there's only 134 people in that study. Well, that study might only need the 134 in order to get to the point it needs. So sometimes you're like, that number doesn't seem like a big enough sample size for what they're doing. And other ways you might go, okay, it makes sense to what they're trying to do, that a smaller sample size is as big as you need for the results that you're looking for. And I'm not saying that's a biased view necessarily when it's super small or results you're looking for, as much as sometimes you just burn out your resources if you're pulling from too much of a sample and you're like, we're still getting the same read. We don't need to pull as much as we thought we would for what we're trying to do here. I hope that makes sense. Oftentimes it makes sense in my brain. Okay, let's simplify it. The characteristic of interest. What do I want to find out? What do I want to find out? The target sample or the target population, who do I want to know about? And then the sample, whom can I study to get accurate answers about my entire population? Okay. All right. Hopefully that helps you. So an example might be, let me double check the page number in the book on this. I'll put it in the notes because I'm realizing I'm using a number from my old book. So a sample must represent a target population. So if we're going to do a sample, it has to represent the target population you're looking for. If you're doing a sample and it's being pulled from here, you're not meeting the goal, which is this population you're trying to get to. If you draw a conclusion from your research, it has to reflect the entire group. So if you finally get your information, right, if you finally get your conclusion, I don't remember what I did with my hands here. If you finally come to this statistical generalization, it must follow and reflect that target population. You have to have the same characteristics in the same proportions, okay? The same characteristics in the same proportions, okay, for it to make sense. But if it doesn't follow the above criteria, if it doesn't have the same characteristics in the same proportions, if you're not pulling from the right target group, and if you're not representing the target group, then it's going to be biased. Again, if I'm trying to get information about chewing gum at Butte College and I only ask my class, that's not the whole entire, that's not the whole target audience here. That's not the population we're looking for. It's just within my classroom. That's biased, okay? A biased sample does not provide adequate evidence to support a conclusion, which is really important when we are thinking about, again, scientific studies. If you're only pulling from, not even your target population, but you're only polling in order to try and get what you want to get out of it, it becomes biased. This is why it's really important, again, that you do peer reviews so that they can recognize, hey, look, we got a question on a target population. Is what you're getting from the actual target population, or are you just kind of like picking and choosing in order to get the results that you want to get, the results, the evidence? My hands are a little confusing on that one. The goal here is, how do we try not to be as biased as possible? Key here, random. Random is your best bet. When you do random also allows you to use a smaller sample size. Again, you could do thousands and thousands and thousands of, polls about, a political view. But if you're doing the right random sample size, you don't need thousands and thousands. Maybe you only need that 1,000. Or if you're doing a scientific study that, you're doing such a good job pulling from random, your random of your target audience, you might only need the 134 participants versus the thousands, right? So if you know that your random is allowing for a smaller sample size, then you might actually get away with it. And again, instead of expanding your resource or sucking your resources dry just to get more random samples when you can actually do a smaller size. Every member of a target population has an equal chance of being chosen as part of the sample when it's random. When it's random, anybody within that target population has an equal chance of being chosen for that, which again pulls away from the bias. All right, if you're like anybody, random, anyone gets to be pulled from there. A truly random sample is generally representative of the target population. If you only have 134 people that you're doing a study on, and you look at that sample of the target audience and you look at that random sample, you should be able to see that it is representing this entire population from that random supply. That's what you should be able to see. Random samples of a target population also reduces the possibility of errors. The more random, the more you're pulling from the target population you're looking for, the less likely you are to have errors in your thing. Again, it could be a small sample size, but it's so random and it shows that it is full on giving everyone an equal opportunity that you're less likely to have errors. Okay? All right, and then the margin of error decreases as random representative samples increases. So the more random you have, the more random within that sample size, the more likely you're going to have less errors. Okay. All right. Again, think of the gum activity here. Who am I pulling from? Where am I getting my information from? Is it truly random? If it is, then again, I don't have to, pull from all of Butte College because that would be a lot of work. I can pull from a good enough solid random sample that would be willing to give me the right answer. Okay. What are some other ways in which we use statistics? Y'all watch football? I totally watch football. They have so many statistics and analytical data on players and games, and it's wild. And there's a lot of people out there betting, so they're putting a lot of information out there. So yes, statistics absolutely in sports. We also talked about politics. We definitely do statistics in politics. Sometimes they'll do maybe like a workplace popularity of certain benefits. I'm trying to think if I've ever had that in a job. What they might do is statistics in the sense of if you have like 5 different options for benefits for healthcare, but you notice that majority of the company is always, the employees are always leaning towards a certain benefit. It might not be worth having others if statistically people aren't choosing that. It might be in the best interest of the company to go with something that is most popular versus having so many options that could potentially be causing, loss of revenue or something because they're still having the option, and because they have the option, it's a cost to it. If they get rid of that option and just lean towards what majority of the people are doing, they can potentially cut costs, which is why statistically they might want to do that. Statistics, healthcare issues for sure. What are the statistics of people with diabetes and heart issues and, stress and da-da-da-da. Healthcare, when you know certain statistics, you can know where you want to lean your science into helping find solutions for. All right. Again, business and profit analysis, obviously. That's business 101 is understanding the statistics of what you're selling and supply and demand. Okay. And then advertising. We're going to get into advertising, and it is one of my favorite assignments. But advertising, the statistics of what people buy and maybe why they buy it, right? What's the statistics behind that? That's when we do inductive reasoning. Maybe we put a pull out, super random sample of people who shop at a certain place or have purchased a certain thing. This is a lot of times why you get feedback when you go to buy something. They send you an email, tell us how we did. And you're always going to get that question, how'd you hear? What'd you buy? Right? they try and make it seem like it's going to benefit the person who helped you, but majority of the time they're just trying to find information that's going to tell them how can they get to you even better. Okay, it's not a bad thing, is it? I don't know. You know, we want to be heard. That's your way of being heard, right? I don't know. All right, something to be mindful of. Recall, some A's are B's. If an A, maybe a B, but nothing is perfect. Meaning we can't prove anything because we don't know everything that this world has to offer. Again, you can't say all A's are B's. Boom, proved it, done. It doesn't work that way. First of all, that's a fallacious argument because not all A's are B's. So when we talk about getting evidence or statistical, evidence, any of that kind of information, we're not proving something, but we are suggesting. This is why people get really upset. This is why sometimes people get upset with science because it's like, well, you said this, but now you're saying this. It's like, yes, because when you think about the history of science, while it's been around a long time, as we get more technologically advanced and we get more information, we start to go, we were wrong. The lines didn't quite intersect like we thought because we're starting to get more information. So we can say we suggest eating an apple a day, but and because this evidence supports it, but we're not proving anything because let's be honest, the more I know, the more I realize I know nothing. Because the more I get information, that tells me what I thought I knew, I guess I didn't know. And this is what's really, really important about critical thinking. You gotta be open to trust that sometimes when you start getting information, don't always trust it, especially if you have that thing in your heart that feels like it's an emotional thing. We'll talk about that a little bit later in some of our chapters, but get the information and look at it and go, well, it's suggesting this, but it's not proving it. Right? It's like, well, it is suggesting this information, but I'm going to step back just a little bit and make sure I get all the information. The more evidence I get, the more likely it is to prove. So, I don't know, say you're watching some news station. Doesn't matter. They're all the same. You get a news station and you get all this information. You're like, oh, that proves it. The problem is oftentimes news stations are leaning in a way to get their particular audience to feed into it and do more. I'm not picking a side. They're all the fucking same. The goal there is to feed you information. But one, it doesn't prove anything. And two, their goal is to give you an emotional response so you'll stay longer and watch longer. That's the goal. It's all manipulative. That's the whole goal of it because they need more people to watch in order for the ratings to go up. And so as the ratings go up, they get paid more. So this is why it's really important as you are being fed information, pause and give it some time because oftentimes that information will change. Also, as we get more information, the goal is to look for hypocrisies in information. You might get certain evidence that is true, and then you'll have someone make a statement on it which doesn't support the findings. Does that make sense? So you always want to make sure you step back as a critical thinker and go, this evidence doesn't support what I was thinking. So now I got to look back and go, was I trying to manipulate and get certain biased information to prove my point, or was someone else trying to do that? So our goal here is we have to step back and look at our information and go, okay, at some point, can I infer that these lines will intersect, or is it true that the numbers were going to stay the same? What does the information and research tell me? That's your goal. That's what you want to look for. So, anywho, that's the biggest part about chapter 4. Let me see one more thing. I just want to make sure. Okay, it's wanting me to save information, so I don't know what I deleted and what I didn't delete, but here we are. Okay. One thing, I just want to make sure I cover everything here. Thank you for your patience. We're almost done. This is probably one of my shorter videos. Okay. When we think of what are some uses of statistical generalizations, Uses for satirical generalizations.